Hello, everyone. So my name is Milena, and I work as a professor at the Faculty of Mathematics, University of Belgrade. And today I'm going to present you a joint work with my colleagues from Sirmia, Ognjen Plavšić, Mirko Brkušanin, and Petar Jovanović. It is about a tool named AutoCheck that we developed for checking compliance with automotive coding standards. I first want to apologize. I have a bit more slides than I should have because I thought that the time slot is longer. So I will have to skip some parts. But if you have some questions later, then I will be very happy to explain everything I skipped. So please move to the next slide. I will start with Autosar guidelines. And can you please move? Yeah, with the Autosar guidelines and the domain of the problem that we are solving. And then I will talk about static analysis in general and the tool AutoCheck that we develop. So next slide. There are numerous consequences of software failures ranging from please next slide. Ranging from light discomforts through big material losses to fatal consequences, including human lives. So software correctness and safety are particularly important in the automotive industry because in this context, software failures can involve human lives. And therefore, we have Autosar guidelines that are tailored to improve security, safety, and quality of software in critical and safety-related systems. Please, next slide. Autosar guidelines contain 402 rules derived from different sources, and these rules can be differently classified according to obligation level, allocated target, and enforcement by static code analysis tools. Some rules can be automatically checked. These are implementation-based rules, and some can be only partially automated, and some cannot be automated at all. So on the next slide, we can see some examples. Here within these rules, some are simple and decidable, like the first one, triggers shall not be used. And then we have some decidable rules that are not so simple, like the continuous statement shall only be used within a well-formed for loop, for example. And here also we have an example of undecidable rules, and these are claims about runtime features, like there should be no division by zero, and this rule is undecidable and difficult to check. So on the next slide, you see our focus is on 340 rules that are implementation based, that can be automated, and that are either required or advisory. As we have seen, there is a big difference between these rules, and some are easy to implement and to check, while some are very complex. And concerning the undecidable rules, total precision is not even theoretically possible. So one must choose between false alarms and undiscovered violations. So on the next slide, you can see that there are different related tools based on static analysis, but these tools presented here aim at checking runtime features and not Autosar guidelines proposed rules. And here there are some exactly Autosar, some tools checking exactly Autosar rules, but these tools chose a different approach than the one that we proposed. So Our objective on the next slide, our objective is to have no undiscovered violations, to have efficient and precise analysis, as we have 340 rules that can be automated. It is very important to be user-friendly tool and to have the usage like usage in compiler, so like compiler warnings, but with additional control over the reporting mechanism. And as a starting point, as you can see on the next slide, we chose to use LVM infrastructure and its most famous subproject named Clang. LVM is publicly available and open source collection of modular and reusable compiler and tool chains technologies, while Clang gives a front end for C-like languages. Clang also provides different interfaces for semantic analysis. And our first important decision was to choose the right interface for the implementation in order to obtain the desired goals concerning efficiency and precision of analysis. So we made thorough experiments, and you can see this on the next slide. We made experiments on a big code base that we first automatically generated in order to explore the behavior of implementations based on different interfaces offered by Clang and on different code structures. And we also measure the efficiency on automotive grade Linux open source code, which serves as an industry standard to enable rapid development of new features and technologies. And this slide, you can see the structure of the code that we generated, and then on the next slide you can see the results of the experiments, where we learned that the interface based on abstract syntax tree visitors, which is offered by Clang, suits better for our needs, and based on these results we continue with the implementation. So on the next slide, apart from these two interfaces, you can see that there is an additional support for more sophisticated analysis, static analysis within Clang, and we also used this support as well because it takes into account control flow graph and not only abstract syntax tree, which is important in case of checking some runtime feature. And this is unfortunately much slower than compilation. On the next slide, something about the tool. We have implemented 190 rules from Autosar C++ guidelines, and some of these rules are language independent or can be used on C code as well. The tool is internally used on projects that require compliance with Autosar guidelines. Please go to next slide. And the obtained feedback is used for guiding the development of the tool. So AutoCheck is an extension of Clang. So plugins for Clang's integration with different software development environments can be used. And here on this picture, you can see how warning looks like when it is integrated within Visual Studio Code. The tool can also, of course, be invoked from command line in the same way as the compiler or Clang. An important part on the next slide, an important part of the tool is how we control the output that is shown to the user. And there are two important options, new options added to our tool that are not present in a standard compiler. First is to limit the number of warnings issued for each violated rule and to stop performing the analysis for each rule after its limit is reached. And the second is to analyze and report warning only between some specific lines. There are also an option to suppress warnings corresponding to macro extensions and to. So please go to the next slide. So concerning other important options, the whole analysis can be performed, or you can check the compliance with each rule separately. Like this one you can see here, fixed with integer types, for example. So there is an option for each of 190 specific rules. So the efficiency of AutoCheck is measured on different corpora. If you can go to the next slide, please. And including sub-projects of already mentioned automotive grade Linux project. And the results show that compared to the compiler, the analysis can take at most 9 times bigger time. More precisely, these differences depend on number of violated rules and the number of times the rule is violated. And on the next slide, you can see some examples. And the important thing is that these two options that I mentioned can significantly reduce these times, because in this file, for example, there are 11 rules that are violated, but these rules are violated a huge amount of times, and especially if headers are included. And in this other example, there is one rule that is violated a huge number of times, and reporting it at each location just takes a lot of time. Just printing the corresponding warning when a rule is violated so many times take a lot of time. But yes, of course, that is something that is necessary. On the next slide, you can see that we checked the robustness of our implementation with running it on Clang's code base. It is a huge code base, and as it is a compiler, not automotive code, it is not written according to Autosar guidelines. So you can see here that there are many rules violated in this code base. So can we go to the next slide and the next slide? So to conclude, Autosar guidelines for C++ language precisely describe forbidden coding patterns in C and C++ programming that are critical in safety-related systems. And here today I present the development and evaluation of the tool named AutoCheck for automated checking of compliance with these Autosar coding standards. There were many different decisions to make on our road, that some of them I discussed and explained during this talk. And our first important decision is that the tool AutoCheck is built as an extension of Clang. On the next slide, please. You can see that we successfully implemented 190 rules from Autosar guidelines, and together with the different options controlling the output in the user-friendly way. And as our road ahead, as our future work, we are planning to implement the rest of the rules. Until now, we obtained both very high precision and very high efficiency of the performed analysis. And that's it. Thank you. Please go to the next slide. You can, of course, contact us, and I will be very happy to answer the questions about our work. Thank you.
Thank you. Are there any questions about this paper? If there are not, I have a question. Did you consider GCC instead of LLVM?
Actually, we did not, because the LVM is, let's say, modular and easily extendable infrastructure, while GCC has parts written in C and not C++. It is not that easily extendable. So we decided to start with LVM.
Thank you. And one presumably short explanation would be appreciated. What's wrong with the warning shown the figure 2, int x equals 10? So what exactly is wrong with that statement?
Sorry, there is a warning in that one slide. It is, I don't know, maybe if I could move back on that slide, on the picture, with the picture, I will read the warning, and then fixed with integer types indicated the size and signage shall be used in place of the basic numerical types. It is a recommendation from Autosar guidelines. So you should use a type exactly stating the size. So it should be int32 type, not integer type. Okay, so because this can be this type, integer type, can differ on different platforms, and Autosar guidelines say that it should be precisely written if you want to use